Aziz not here kan? Belum lagi ya? Is he coming ke tak? Tadi dia ada ya? Cuba message dia. Ataupun can you start dengan yang the first group dulu?
Boleh. Okay, sure.
Okay. So for the first group, so we look at the first question dulu. I mean question sama je kan? I mean kejap mana soalan ni? Soalan aku dah tak jumpa dah. Can you display also the question kan? Boleh tak?
Sekejap. Sebenarnya sebab saya share tab, so ada Google Drive je.
I mean dia punya tajuk sama je kan? Replacement algorithm. Okay lah, so I think the first group can start. Then we just look first at your presentation lah.
Okay, saya start.
Okay.
Assalamualaikum to Dr. Yamani. My name is Ahmad Ahmad Birazak, and here my group is going to present page replacement algorithms for our second lab. So these are our group members. So we are going to present a FIFO page replacement, which is first in, first out. So FIFO is a method of processing and retrieving data. In a FIFO system, the first items entered are the first ones to be removed. In other words, the items are removed in the same order they are entered. So to use a real-world analogy, imagine a vending machine where the items are loaded from the back. When someone selects a KitKat bar from row E5, the machine churns out the chocolate bar closest to the front. The next KitKat in line then moves to the front. Therefore, using the FIFO method, the chocolate bars are dispensed in the order they were placed in the machine. So computers often implement the FIFO system when extracting data from an array or buffer. If the first data entered into the buffer must be extracted first, the FIFO method is used. So this is the illustration, and I'm going to pass to Ilham.
Okay, hi, my name is Muhammad Ilham. So here we got our reference strings, and let's see all of this is for process 1, and process 1 consists of pages, and all of this is pages for the process 1. So here we got our main memory, and it consists of 3 frames. This is frame 1, frame 2, and frame 3. So first here we got our first page is 7, and here we see that this is empty memory, and there is put 7 here, and this is considered as fault, page fault. So next we got 0, so just copy 7 and put 0, consider as fault 2, and next 1. Okay, next we got 2. So here we see that this memory is full. What we do is, because this is FIFO, first in, first out, we must take 7 out from the memory. So 7 out, and we put 2, 0, 1. Next we got 0. We already got 0 in the main memory, so just write it back to 0, 1, and this is considered as hit. Next we got 3. So 0 is the longest one that stay in the memory. Okay, so we take away 0 and put 3, 2, 3, 1. Next is 0, and 1 is the longest one. Take out 1, so it's 2, 3, 0. Next is 2, 4, 3, 0. And 4. And next 2. So take out 3, 4, 2, 0. Then 3, take out 0, 4, 2, 3. So next one is 0, take out 4, 0, 2, 3. 3, just copy it back because we already got 3 in our main memory. So next one is 1, take out 2, 0, 1, 3. Next is 2, take out 3, 0, 1, 2. Next one is 0. So this is fault, 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 and this one is hit. This one is fault, this one is fault, and this one is hit. So this is how our memory work, uh, and for the hit one, we say this is 201, and for this one, so 701, 7 will move to the disk, and 2 will go to the main memory. This is main memory, this is this. So next we are going to calculate the ratio. So for the hit ratio is a number of hits per total number of reference. So we got 3, 12, 50, and 100. And let me calculate. %20. Okay, so for the page fault ratio, we got 12 per 50 times 100, and we got 80%. So this is how we do the FIFO mem.
That's all from me, and I will pass it back to Aiman. Thank you.
Right now, I'm going to present a bit with the flow chart. So this is the flow chart for first in, first out algorithm. So first, we'll start the system. It will request user to enter number of page. So if the input is numeric, then it will ask a user to enter page number. If the page number is a numeric input, then it will ask user to enter number of frames. So if the frame is a numeric input, then the system will read the input. Then it will sort page into frame. Then if the frame equals to -1, it will allocate page into frame. Then frame will be created. But if frame is not equals to -1, then if pages is equals to the incoming page, then a frame will be created. If no, then it will remove first in page into this, then it will insert new page into the removed page, then frame will be created. So after frame created, if frame created, then if the page input is equals to number of page, then it will count fault pages, then it will show the fault pages, then it will end the system. So I will pass to Wafiq.
Thank you, Aiman. So, for the coding part, first we will ask the user to enter the number of pages. Here we enter 15 as stated in the video. And next, this is the list of the page number. The number of frame is 3. Here we can see this is the memory illustration, main memory illustration for this programming, and the page fault is 12. The ratio and the hit ratio is 80%, which is unacceptably high failure rate. And that's all from us. Thank you.
Okay. So yang the other group do another algorithm, is it?
We do both for the illustration, but for the code on the LRU.
Okay. So okay. Alright. Okay, can you present? I mean the first one LRU have you presented? Tak payah ke macam mana?
Mm,
Your LRU?
For presenting, I thought we agreed for first in first out only.
First in first out. Tak apalah. Okay lah. Never mind. So the second group lah can proceed with the LRU, is it? Ke FIFO? You did both kan macam mana? The second group.
Description and illustration, we make both, but for flowchart and code explanation, only LRU.
Okay lah. Should be okay. Alright.
Assalamualaikum and good day to Dr. Yamani and to my fellow classmates. My name is Khaira Azizi bin Khairuddin.
Hello, doctor and everyone. My name is Lin Fanzhi.
And hi, my name is Nurul Aina binti Azrin.
Today we will be demonstrating Lab 2, which is regarding page replacement policy.
In an operating system that use paging for memory management, a page replacement algorithm is needed to decide which page needs to be replaced when a new page comes in. Whenever a new page is referred to and not present in memory, page fault occurs and the operating system replaces one of the existing pages with a newly needed page. Different page replacement algorithms suggest different ways to decide which page to replace. The target for all algorithms is to reduce the number of page faults. Two most popular page replacement policies. First in, first out. This is the simplest page replacement algorithm. In this algorithm, the operating system keeps track of all pages in the memory in a queue. The oldest page is in the front of the queue. When a page needs to be replaced, the page in the front of the queue is selected for removal. Second, least recently used. In this algorithm, the page that is used least recently will be replaced.
This is an illustration of how the first in, first out algorithm works. As we can see, we have a list of pages in a queue to be placed in the frames. The first page is 1, and as the frames is empty, we place it in the first frame. Since page 1 is not in any of the frame yet, the page fault occurs. Next is page 3. So we insert it in the second frame, and there will be another page fault. Next is 0. So we insert it in the last frame and it is also a page fault. Then we move to the next page. It is 3. As we can see, our frames are already full, but since 3 is already placed in the frames, so it will remain there. Then we move to page 5. Since the frame is already full, we need to remove one page from the frame. So we will choose the first in page, which is page 1. So we remove it and replace it with page 5. It is also a page fault. The last page is 6. We will look for the first in page, and it is 3 now. So we remove 3 and replace it with 6, and it is a page fault. Now let's calculate the failure rate. Since we have 5 page faults out of 6 placement, our failure rate will be 5 over 6 times 100, and it is equal to 83.33%. That is how first in, first out algorithm works. Now, let's see how the least recently used algorithm works. So as you can see, we have a list of pages in a queue and 4 empty frames. First, we take page 7, and since the frames is empty, we place page 7 in the first frame, and it is a page fault as page 7 wasn't in the frame before. Next, we place page 0 into the second frame, and it is also a page fault. Then page 1 in frame 3 and page 2 in frame 4. As you can see, our frame is already full, but since the next page is 0, which already in the frame, it will remain the same. Next is page 3. Since page 3 isn't in the frame, we need to remove the least recently used page, which is in this case is 7. So we remove 7 and place 3 into the frame, and it is a page fault. Next is 0, so nothing changed. Next we have page 4, so we need to remove the least recently used page. As we look back, we have 0, 3, 0, 2 and 1. So we remove 1 and replace it with 4 and page fault occurs. Next we have 2, so it remains the same, and then 3, then 0. So nothing changed. So now let's calculate the failure rate. Since we have 6 page faults out of 11 placement, our failure rate will be 6 over 11 times 100, and it is equal to 54.54%. That is how least recently used algorithm works. Now let's look at the analogy between FIFO and LRU. For FIFO, the first page in the queue is selected for removal, while for LRU, the least recently used page is selected for removal. Next, for FIFO, it is little overhead as there is no need to keep line of the pages, while for LRU, it is more overhead because you have to keep line of time when the pages were used. Now, let's look at the flowchart and programming explanation.
Okay, now I will continue the code explanation and the flowchart. So here is the flowchart for LRU, which is the least recently used algorithm. Okay, so we start by initialize the linked list, page array, and the frame capacity. So here, initialize the link to contain the final page, and the array to store the page reference string and our frame capacity. Here I have made a method to do the algorithm, LRU method here. So here we will initialize the array list for index, the size, and set the page fault and LRU index to 0. Okay, here I have set these 4 things, and the index here is to track the least recently used index. Okay, after that, we will traverse in a loop to do the page replacement according to least recently used algorithm. So here, okay, when the size is smaller than frame capacity, if yes, add the page to the page linked list and increase the page fault and add the index position of the page. Okay, here are the code. When the size is smaller than capacity, okay, I will add the page to the memory, then increase the page fault and add the index of the page to keep track of the LRU index. Okay, when the size is bigger than frame capacity, we will check for if the linked list has already contained a page or not. Okay, if yes, the index array list set the index of the current page index. And if not, set the page that is the LRU index to the linked list, and then set the current index as the LRU index and increase the page fault. Okay, here, back in the code here, what else? If links contain the page, so the index array list that keep track will set the link, the index of the page to be the index here. Else, we will replace the least recently page with the new page here, and then we will keep track of the LRU index and then increase the page fault here. Okay, after that, we will find the minimum value in the index array list, and we will increase the size here. Okay, so here we will find the minimum value in the index array list, and then we will increase the size here for the loop to check for this part. Okay, to demonstrate, for example here, so yeah, we have 4 capacity here, so this will be the page fault. Then we move to 0. 0 has already in the memory, so we will, and here we just keep track of the existed page in the memory. And then we traverse, and this 3. So 3 is not already in the memory, so we will replace the least recently used index, which is 7 here. So here, put here we will replace 7, which is the LRU index, with the new one, which is 3. Then we will keep track of the LRU index and increase the page fault. Okay, so that's how it works. And now back to here. we will print the result and end. So here is our result here. So I will run this code now. Okay, so the total page fault is 6. So final page is 3042 here. And I think that's all, and thank you.
Okay, I think quite clear, isn't it? Okay, so only apa tadi? The hit punya ni you tak masukkan The hit ratio.
Tak masukkan.
Should be okay lah, isn't it? Okay, so any question for I think it's straightforward kan? Semua you guys can understand the method, I mean the algorithm.
Yes.
Yes, betul.
Okay. So there is another algorithm, isn't it? The optimal punya method. Well, I'm not sure whether they covered ke tak dalam syllabus, but normally okay in this kind of algorithm there is a FIFO, LRU, and also the other one is optimal lah. Okay, so it's quite straightforward. Okay, only that in terms of later on, maybe next punya programming, I think better to use debug lah. I think you can show the value kan, the current value and also the next value lah. Boleh, you all biasa guna kan debugging? Hello?
Yes.
So because masa what do you call when you explain on the code just now, I think it's easier if you can use debug and then show the value lah, because of its what do you call it, the loop just now you can get the initial, I mean the value lah every time it travels from one step to another. Okay, so others I think should be okay lah, no problem. Okay, it's a good presentation both of the group. Okay lah, I think itu je lah kot. Alright. Okay, so if nothing else, I think you can proceed with your the next lab, and then just compare. I mean, just prepare again the presentation for next week. So if nothing else, then I think we can end the session lah.
Okay.
Ada apa pun nak tanya ke?
No, Doctor.
No
Okay.
question.
Okay, so for but for apa tu? Just sorry lah just now because of I thought the class is start at 3. Okay, so so next week the class start at 2 lah. Supposedly, if anything has to be changed, or I already join your chat group. So if anything I wanted to change ke apa, then I just message in the chat group lah.
Okay.
Okay. Alright. Okay, thank you very much.
Thank you, Dada.
Okay, thank you.
Thank you, Dada.
Thank you.